the IWE system on the F150, outlined on a whiteboard. Doesn't get much more boring than that, but please stick with me. I will make this short. So your IWE system is what actuates the front locking hubs on the left and right front wheels of an F-150. The years that it applies to, I don't know, to be honest. You can look that up. If you're looking into this, you already know. So you have 5 main components that are in your system that could fail and are probably bad if you're looking at this video. The actuators, those are on the wheels. Each of the wheels has one that is locking itself to the hub and therefore allowing four-wheel drive to power transfer from the transfer case through the wheels. Your lines, we'll look at those in a second. The solenoid, which is just an on-off switch to supply vacuum. Reserve tank, a surplus of vacuum. And then your check valves, you've got 2 of them. The smiley faces don't apply here, just so you know. So this is Underhood, looking at the front of the vehicle, driver's and passenger side here. Your engine is supplying a specific amount of vacuum to your system. It's probably something like 20 or more inches of mercury. I'm not going to measure it, but you can just take my word for that. So the engine is supplying vacuum through the lines and to the actuators. You've got a pair of check valves, one here and one here. You've got a solenoid and you've got a reserve tank here. So the lines run through the first check valve. If this check valve is working properly, vacuum can't escape back out this way, to a reserve tank, and then through another check valve. Again, if this is working properly, vacuum cannot escape through this. And then you have your solenoid. Now the solenoid is literally just an on-off switch. So you're going to have vacuum constantly supplied to the solenoid when the engine is running. As you get up in the RPMs in the engine range, you actually lose vacuum for the most part. You'll get closer to atmospheric pressure. And so that's where your reserve tank plays a part here. It actually is able to store a reserve amount of vacuum. When you lose engine vacuum, it can step in if it needs to, if you got a leak in your lines or something like that. So what happens on a failing system, if you have line leaks, as you're cruising on the freeway, you're slowly dropping that vacuum level. And while you're in two-wheel drive, you're looking to have a lot of vacuum because you need to pull these open. When you lose, when you're up in the RPMs, like I said, you lose vacuum from your engine naturally, and this reserve tank is going to be depleted. You'll get to a certain point where this is depleted enough, where the solenoid then cannot supply any more vacuum to keep these open, and you will actually close these, and they'll try to close while you're driving down the freeway. So back to the beginning. You start your truck up. It's in two-wheel drive. The solenoid will open, which then allows vacuum to fly or flow through into the actuators and disconnect your front end. Now, if you close your four-wheel, you turn it into four-wheel drive mode, this then closes, taking vacuum away from your actuators. It has a vent to atmosphere, and then these actually close and engage your four-wheel drive system. Likewise, when you turn your truck off, you lose vacuum and your actuators will engage and all 4 wheels will be locked. So just said another way here, engine running, you have vacuum. Vacuum opens your solenoids, or I'm sorry, vacuum opens your actuators, and no vacuum will lock your actuators. As your RPM goes up, your vacuum goes down. That's why you have a reserve tank. And the replacement steps are as follows. Check your solenoid, check your check valve, make sure both of those are functioning. You're going to see that here in the video. Your lines, check your lines for leaks, and then check your actuators. I would say these steps probably happen at the same time. Check these first, and then check your lines. Now let's go take a look at the truck and test these things live. So we got our IWE system under hood here. So you've got your solenoid, you've got power going to your solenoid. It's just 2 wires. It's going to be on or off basically. You've got your feed wire from the intake manifold. So intake manifold, you've got a splitter. I think this is a check valve in itself. Comes down to the brake booster, and then you have your T-off line. This actually might be the check valve built into the brake booster. Don't quote me there. But the line comes up and over to your IWEs. Here's your IWE check valve. We can check that, check the check valve. I'll show you how to do that. And then your solenoids. So you got your input, and when the truck is turned on in two-wheel drive, this will be supplying vacuum. And the reason for that is that you want your IWE solenoids to open. So they're usually engaged, opening pulls them back, and with vacuum, they're disengaged. So when you turn your truck on in two-wheel drive, they will disengage. And that's done by the solenoid. When the vehicle's off, you lose vacuum, and then they engage, so your truck's in four-wheel drive in park. Now, this line here, like I said, goes to the IWE system. You can check this by pulling it off and applying vacuum, and I'll show you that now. And this here, you can actually check to make sure you have vacuum coming from the engine, and you can check by pulling each side of this check valve off to make sure you have vacuum at your, or vacuum here and vacuum here. I'll show you that in a minute. So beyond that, you have your reserve tank here, and you've got a line that comes off here going to the opposite, or the open side of the check valve. So the valve is actually here, therefore this tank is on the solenoid side and is always helping to supply vacuum. And then you've got your IWE actuators, which are on the inside of your wheel. You can see it here. That's your IWE actuator on one side. Mine's got a lot of grease residue because mine is over greased, but it's still working. You've got one on each side, and you've got a line that comes down. I showed you in the diagram that tees off to each side of this. So let's test the lines, and we'll test the solenoid itself. So I've got the Mighty Vac from Harbor Freight hooked up to my lines that go to the IWEs, and we're going to start applying vacuum. As you climb up, this is in inches of mercury. You can see we're struggling a little bit to get vacuum, and then you're going to get to a certain point where it just spikes. Right, now your actuators are fully open, and you can hold that for a couple minutes. So we're just going to hold this for a little while. My lines are brand new, so they're going to hold vacuum very, very well. If I see a leak, I'm probably just going to sell the truck at this point. Okay, that's holding very well. So let's go on to test the check valve and make sure the solenoid's functioning properly as well. Okay, to do this, you're gonna wanna start your truck, leave it in two-wheel. You're gonna have a little bit of extra engine noise from me here, but bear with it. All right, so what I'm gonna do first is pull off this bottom line. This is the one that's coming from your intake manifold. Oh, I pulled off both. That's okay. You can hear we have good vacuum. But because we're in the two-wheel drive mode, there is vacuum coming through the solenoid. So that's pulling our IWEs open, and therefore two-wheel drive. Right, now if I want to check my check valve, what I can do is pull off this side. Okay, we got vacuum there. Now what I want to do, no vacuum coming out of this, and then pull this off at the same time. And we should hear vacuum coming out. And that's how you know your check valve's working. Yep, there it is. So your reserve tank had vacuum in it, your lines had vacuum, and it was holding just fine. So your check valve is doing good. If you let it sit for a little while longer, that might be a little bit more validity, but I had vacuum after a couple of seconds of sitting, which is plenty. So this check valve is working great. If you have no vacuum on that side, it's probably leaking, and you should replace this check valve. They're very cheap. I'll link below. And I guess as a side note, I broke the connector on mine. That's why there's 3 zip ties holding it together. Don't worry too much about that. Maybe don't break the connector like I did. So that's what your line situation looks like. Now we're going to test the actual solenoid itself for functionality. So we're going to pop her into 4-wheel drive, 4x4 shift in progress. And now we should have no vacuum at the top. No vacuum. no vacuum. So that means that this solenoid now closed. No vacuum is being applied to the 4x4 actuators. It vented everything to atmosphere from the top, and our hubs are now locked in place, or at least theoretically they should be. Now, if with this system functioning the way that it's supposed to, your actuators are still engaging, your actual actuators on the wheel ends, these guys here are likely your culprit. They're either stuck, engaged. This is if you're in two-wheel drive mode, you're intending to be in two-wheel drive mode and it's still engaged. Likely these guys are your culprit if all vacuum system tests are passing correctly. Then I would take a look at replacing your actuators, which sucks. Good luck with that. The integrated wheel end and how to test it. So I've got my vacuum set up right here. I've just got it plumbed to the big port on this guy. And you can actually see it down here. Now, I'm going to illustrate how this thing actually works because it's pretty neat. So I'm going to move the hub, turn the hub with my hand so you can see the hub moving, right? So basically, those teeth that are right above the spinning ones, engage with the axle hub all the time. And when the integrated wheel end has vacuum, this hub moves up and it disengages with the actual hub that connects to the wheels. So let me show you. I'm going to get rid of vacuum. Now, they've tried to disengage, but they can't mesh with each other because they're not lined up. In reality, what would happen is this guy would force them to align, but let me just apply a little vacuum. You'll see it start to move. Perfect. Now, I'll line them up perfectly, and so now when I release, boom, four-wheel drive is locked, four-wheel drive is engaged. So now those middle teeth that move can engage with both the CV axle and the wheel hub. So that's how your IWEs work, integrated wheel ends. And the grinding noise you're hearing on the freeway or wherever you may hear it is when you lose vacuum. So we'll move this once again. When you lose vacuum, they're just trying to engage. That middle hub ring that moves is trying to engage with the hub on the freeway, and you're getting that really, really nasty noise. And eventually it'll just wear out the hub ring or the IWE completely, and you'll never be able to use four-wheel drive. So you don't want to do that.